Hello everyone, welcome to the video on types of data. What are the different types of data that we can have in our data set, right? Let's take the student example that we have considered in our earlier videos. What is the student example? A student studies for certain number of hours and scores some marks, right? So marks is the dependent variable, a number of hours studied is the independent variable. We also included an additional independent variable, number of questions asked by the student. We will take this example and understand the different types of data, right? If you look at this particular example, it is all quantitative, right? That is the basic distinction. We can have qualitative data or we can have quantitative data. This is quantitative data, this is quantitative data, and this is also quantitative data, right? There is no qualitative data in this. Then we looked at another scenario. We used the same set of independent variables and changed the output or the dependent variable, right? That is, we try to find the grade obtained by a student based on the number of hours studied and the number of questions, right? Grade can be what? It can be A, B, C, D, E. Grade assigned to a student based on the marks, right? I am not predicting marks, rather I am predicting grade directly. So this is a classification problem, this is a regression algorithm, right? So that is the first thing you need to understand. This is a non-numeric variable, you all will understand, right? We also looked at one more example, whether a student will be topper or not. Whether a student will be topper or not. And we used the same set of independent variable, hours and number of questions. If you are wondering why I am saying we already covered, I covered this example in detail in another machine learning basic series video that is on dependent and independent variable and also classification and regression algorithm. I explained these examples in detail. Okay, if you are interested, you can go and watch that. So this again is a classification scenario. What can be the output in this, whether a student will be topper or not? It is yes or no, right? It is yes or no. All these are numeric variables. Clearly, this is a non-numeric and this is a non-numeric. Okay. Now, marks, is it continuous or discrete? Marks can be written as 80%, or I can write it as 80.2, or I can write it as 79.8. I can write it as decimal points. That is continuous, right? If you ask me how many students are there in the class, I will say that 46 students are there in the class. Can I represent 46 as 46.1 or 45.8? I cannot, right? Whereas marks, I can represent it as 80, 80.2, 79.8, so on and so forth. That is, I can break the data into smaller dimensions in continuous data. In a discrete type of variable, I cannot split this, right? Let's say a manufacturing scenario. How many products were manufactured in an hour? 120 products were manufactured. What is the average width of the products manufactured? I can say it is 4.6, let's say mm or cm, right? And if it is 4.6 cm, I can represent this as meter or centimeter, right? That is why whenever you have decimal, it invariably is a continuous data. That is, I can represent this data into either higher dimensions or lower dimension. Whereas in the case of discrete, I can represent it only as a number. I cannot change I cannot represent this as a 46.1 or 45.9 kind of number, right? That is, it cannot be subdivided. That is the key terminology you need to use. Can I subdivide this measure? If it is yes, it is continuous. If it cannot be subdivided further, then it is known as discrete data. Right? Now let's come to qualitative. Marks is clearly a continuous data, right? A regression algorithm. In classification, the output will be qualitative, non-numeric. Whether it's going to be binary, ordinal, nominal is what we are going to see now. Binary is what? Yes, no, good, bad, go, no go, a decision point, right? Whether I'll go for a decision or not go for a decision. That is binary. Then what is nominal, ordinal? Binary is clear, right? I think you are all clear about binary. In this case, the output is binary. Let's take this scenario, grade. Is it nominal or ordinal? We all agree that it is qualitative data. Then what is this difference between nominal and ordinal? Ordinal is an ordered set. Like in grade, A is number 1, B is number 2, C is number 3, D is number 4, E is number 5, right? It's an ordered set. I can say that someone who has got an A grade has obviously scored more marks than someone who has got an E grade, right? Someone who has got a B grade is better than a student who has got a D grade as far as exams are concerned. So I can do an ordered or a ranking. An order or ranking is possible in ordinal data, and ordering or ranking is not possible in nominal data. Binary is only two things, right? When you have more than two only, you look at nominal or ordinal. And when I have an ordered ranking, I use ordinal. When I don't have ordered or ranking in my data, or ranking is not possible in data, I will categorize that as a nominal. Can you think of an example for a nominal data? Think blood group. Blood group of students is nominal data. I can't say that O positive is better than B negative. Although B negative is rare, O positive is more common. But I cannot say that O positive is higher than B negative. There is no pecking order here. So whenever you have an ordered set of data, right, that particular type of data is known as ordinal, right? So you may ask this question, why is this relevant for machine learning, right? You always ask the question, whenever you understand concepts, always ask, why is this relevant for machine learning? This is very much relevant for machine learning because all the algorithms, right? We want our data to be quantitative, not qualitative. So you cannot have qualitative data in your data set for the purpose of developing machine learning algorithms. So then you will have a question, what if I have qualitative data in my data set, sir? You will have to convert qualitative into quantitative. Qualitative data must be converted into quantitative data through a process known as encoding. Is encoding an accurate method? No, it is only an approximation. Please note that this qualitative to quantitative conversion is only an approximation. But still we go ahead with it because the algorithm cannot have non-numeric data, as part of the data set. It must be converted. We will talk about encoding and how we do encoding, in another lecture series, in another lecture. Okay. So what I wanted to cover in this is qualitative and quantitative. That's the two broad types of data categorization. Within quantitative, you have discrete and continuous. Discrete data cannot be subdivided. I cannot represent 46 as 4.6 or 4.5 or 46.2. I cannot do that. Whereas a measure like 4.6 can be represented as 4.61, 4.58. I can even represent this as 5. I can round it off. I cannot do that. Subdivision is not possible. In qualitative data, binary is yes or no, good, bad, go, no go. Only two options are there. Ordinal is ordered data, right? Like grade. Nominal is there is no order, right? There is no ranking that is possible in nominal type of data. We will have all types of data in our data set. As I said, if you have qualitative data, we must convert it into quantitative data. Okay.